here we're asked to simplify this expression, and there is a lot going on here. But if you focus in, we notice that we are adding and subtracting these different terms. So we're going to go through and simplify each of these terms individually, and then we can add and subtract them together. So let's look at the first one. We just have 5x, and there's nothing else we can do to 5 times x. So we're just going to leave that as 5x. If we look at the second one, though, we can simplify this a bit. This is saying x to the third times x to the fifth. When you have two numbers where the bases are the same, so if you look over here in the green example, the bases are the same, they're both x's, but the exponents are different and you're multiplying, what you do is you add the exponents. That's a shortcut. What this is saying is x is being multiplied together 8 times and x is being multiplied together 4 times. So you're just asking yourself, how many times in total is x being multiplied together? 8 plus 4 more is 12. So in this case, how many total times is x being multiplied together? 3 and then 5 more is 8. Now let's look at the next one. For this one, we're going to be using the power rule. When you have something with an exponent raised to a power, like y to the third raised to the fifth power, then you use the power rule where you can just simply multiply those exponents. So if we look at the example over here on the left, what this is saying is x to the fourth raised to the third power. So x to the fourth is being multiplied by itself 3 times. So 4 and 4 more and 4 more is 12. Or you can think of it as there's 3 4s, that's like 4 multiplied by 3, and that gives us this 12. So in this case, we have y to the third to the fifth power, so we just multiply 3 times 5 and get 15. Now the next one is also the power rule. I'm going to rewrite it down here. X divided by y. If there's no exponents, we assume that the exponent is 1. Also, it's important to know that if you have an exponent to a fraction like this, you take that exponent and you multiply it by the numerator and the denominator's exponent. So this is saying x to the first to the third power, and also y to the first to the third power. So x to the first to the third power is x to the 1 times 3, which is 3. Y to the first to the third power is y to the 1 times 3, which is 3. Now there is one other thing you need to pay attention to when you're using the power rule. This only applies to the components of your term that have exponents. So if we look here in the purple, what this is saying is x to the fourth to the third power, just like above, that gives us x to the 12th, but this is saying 2 to the third power, which 2 to the third power is 2 times 2 times 2, which is 8. So watch out for that. Like this one over here is saying 2 to the fourth power, so I'm just going to write that as 2 to the fourth power first. And then x to the 6th to the fourth power is x to the 24th power, and x to the second to the fourth power is, y to the second to the fourth power is y to the 8th power. Now we can put in our calculator and simplify what is 2 to the fourth power, and 2 to the fourth power is just 16, so we can change that. Now the last step after you've simplified each of these terms is to look to see if we can simplify it any further, if we can combine any like terms. Now I'm reminding you in orange down here, like terms have the same variable and the same exponent. So you might notice a lot of these have x's, like this has an x and this has an x, but this is x to the first and this is x to the 8th. So those are not like terms. This has an x, but it also has a y. So that's also not a like term. or this has a y and this has a y, but again, one of them just has a y, the other one has a y and an x. So in this case, each of these terms are different. None are alike that we can combine. So this here would be our final answer.